Why did this guy bring a whiteboard? Well, here's the. When I rewinded my videos and saw them on YouTube, I realized they were very boring. So boring that I didn't even watch a video for 1 minute full. If I watched them, then I would be officially breaking a new record. So I decided, why not bring a board? That way it won't sound like I'm blabbering nothingness. And it will also be more interesting, and at the same time I can explain better. So here I am with a new board. So what is the topic? How to terraform the moon. First of all, gravity. The moon has 6 times less gravity. How do we conquer this? Atmospheric pressure. When we get to the atmosphere, we install 6 times more atmospheric pressure. That way, it will be like the same gravity as Earth, because the force pulling down will be the same as Earth. So then there is the problem of lung suffocation. But space suits conquer that. So whatever we end up doing with that, let's go over to the atmosphere. Challenge 1. The atmosphere. The moon, as we know, has no atmosphere. Literally no atmosphere. So where do we get all that oxygen and etc? Well, I did some research and I found out that there are some compounds on the moon that do have oxygen. So, and we need a laser with 20 petawatts of energy to feed that oxygen, which is 2 times stronger than the strongest laser ever invented. This is a humongous amount of energy because it's 2 times 10 to the power 16 watts of energy, which can heat something up to about 5,500 degrees Celsius, about the surface of the sun, plasma level, which will turn into a hot hair of lava. So then it rapidly cools down, and a strange snow starts to fall down. You may ask, why snow? The ashes of the elements from the compounds. That's the stage 2 that's falls down. Now we have a super cold planet. Okay, it's not even that cold, but yeah. Now we do have oxygen, right? Good. But we need a lot of it. We can either cut chunks of ice off Europa, a planet that is orbiting Saturn, and automate the process and use sky tethers to bring it up from planet to planet and get it to the moon. We have already launched successful missions from the Earth to Saturn. So this should take a few years to get to Saturn, and importing the ice itself will also take a few years. And now how to automate it? How do we automate the process? First, since the moon itself doesn't have that much gravity, but Saturn does, we can use electronic rings that shoot it up. Once it reaches the moon, it will gently fall into its atmosphere, and it will rain down as snow. and then we just inject the hydrogen. And we already have the lasers. So again, power up the lasers and oxygen again. And again, and now the atmosphere has, and now hydrogen, but the hydrogen blends in with the oxygen atmosphere, which is a problem, and falls down. But at least it's breathable. But how do we make the soil fertile? Once again, with the help of this giant laser we have right over here. By turning it on and off in rapid succession, we can break it down into smaller and smaller chunks until we finally get something that is minuscule chunks. Add a little water, which is already there on the planet, and you get a sort of dark mud. Now how do we make it? And now we have to fertilize it. Add some cyanobacteria and which turn nitrogen and other things into useful compounds that can be used by more complex organisms. And the nitrogen in the atmosphere we can get again from Europa to here. Now we have a very fertile moon. But it's no better than a desert on Earth, except it has water. We have to start introducing life. The first life we can introduce is photoplankton to our young oceans. We know that around 3.5 billion years ago, it was responsible for turning the toxic atmosphere of the Earth breathable for more complex organisms. So we have now installed the photoplankton, and the Earth and Moon aren't even that far away. It will take 3 days at most. And rocket missions from the Moon also require less fuel, 6 times less fuel to leave. But the distance is a whole different thing. It doesn't require that less fuel, though we do have to minus the distance from Earth to Moon, which is already made and also benefits other things. But there is a problem we haven't addressed yet. How did Mars become uninhabitable after those years? Like, for those of you who don't know, Mars was once very habitable planet until its weakness was exploited by the solar wind, magnetic field. The solar wind just dried off all the water, and now Mars is a landscape of rust, or FeO2 as its chemical name. So last we have to install the magnetic field. But you might be like, Earth's magnetic field. What about the Earth's magnetic production? What about when the Moon comes over here in front of the Earth? That won't happen that often, but it will eventually happen enough so that we have to repeat the process again. So we have to install a magnetic field over here. This has to be about as big as the Moon's orbit. which is bigger than Earth, because the moon will also be over here exposed, and here exposed, and here, and so on. So it has to be a little bigger than Earth, as because the moon's orbit diameter, which means it will take a lot of time. But you are forgetting the snow on the moon. We can collect the snow and take out pieces of conductive elements too, and from it. And we kind of forget that we have a Skythicker network over here, or in other words, Skyhook network that can launch things from Titan to, Europa to Europe. But the moon's gravity and asteroids, strong materials, and we can just make it out of iron and other materials. It doesn't even need to be complicated at all. So for now,